Hello everyone, and welcome to another workshop in the Polaris Hackathon series. Today we have a special workshop on C# smart contract tutorial. With us is Harry Pearson, the chief software architect of Neo Enterprise. Uh, Although I think lots of people have know about Harry, but in case someone else don't know about you, Harry, please give everyone a self introduction, please.
Yeah, sure. My name's Harry Pearson. You probably know me online as DevHawk. I am the chief software architect for NGD Enterprise, and I am the primary developer and driver of the Neo Blockchain Toolkit, a set of industry-leading tools for blockchain developers on the Neo platform to allow you to better develop your smart contracts. In that toolkit, we have Neo Express, the debugger, the test framework, the visual dev tracker, and Neo Trace. And we're always continuing to improve that tool set. With Neo 3.2 around the corner, we'll be shipping a new version of Neo of the toolkit that corresponds with 3.2. And I did a devlog a couple of days ago about the blockchain toolkit, and of course we will see it in use fairly significantly today as we go through C# development.
Okay, thanks. So are you ready to start your presentation?
Yeah, I'm ready to go.
Okay.
So one of the things you get with the as I mentioned, there's a couple of tools. Now we're going to be doing C#, but I'd like to point out that the underlying toolkit is multi-language. So the debugger, Neo Express, Visual Dev Tracker, these things all work regardless of the language you're using. I tend to be a C# developer. The underlying Neo platform is built in C#. I used to be a member of the managed languages team at Microsoft, so I'm very comfortable in C#, so that's what I normally use. But nothing with the exception of, obviously the code I'm going to show today is C#, but generally speaking, most of the things I'm going to show you today can be done in any programming language. This is not only C#. So the first thing I want to show off here is this project called Devlog Sample. I like to make sure all these samples that we work on get published. This one is not at this time published because it's basically just what the next template's going to look like. So if you've ever used Visual Dev Tracker before, you'll know that there's this section here at the bottom for Quick Start where you can create a, where is it? There's somewhere in here, there's an option to be able to say, I want to create a new contract. And this is kind of the template that you get. It gives you an option about deploy. Okay, I can't find it right this second, but we will find it later. It gives you an empty contract that you can fill in. There's also in the C# space, there's a tool called .NET, the command line tool, and it has a operation called new. We're going to ship this as a template for .NET new as well. So this is going to basically be the empty token. All I've done is change the name to devlog token and change the namespace to something specific to me here. And I just wanted to quickly walk through it, a couple of things, and then we're going to look through a much more interesting contract called Safe Purchase, which is absolutely available for you to take a look at and is much more comprehensive and shows off some really interesting business scenarios. So there's a couple of things that I like to point out about this contract, right? So there's a bunch of attributes here at the top, and you inherit from smart contract. And then the basic contract includes information about managing the contract. It's really important to remember to get this information set up because one of the things that's interesting on the Neo platform is that you can actually update your contract when you without changing its transaction hash. On other blockchains, of course, there are a variety of systems that provide proxies or cutouts so that you invoke a contract and then it in turn invokes, looks up some data and invokes the contract that the data tells it to invoke. Here, we've got that infrastructure built directly into the platform. And you, of course, can check to make sure that all the information about what version of the contract is deployed is available to contracts. So when you go to actually invoke a contract, you can check to make sure it hasn't been updated for security reasons. But it's really important when you actually create your contract to lay out the infrastructure from the beginning that will allow you to manage the contract going forward. So when we do a normal contract with C#, we create a deploy function. So this function here, deploy, you see that it has this display name attribute _deploy. The underscore, any kind of method that has an underscore as a name, that starts with underscore as a name prefix, cannot be invoked from the outside, right? So I can't call the deploy method even though it's public. However, the core infrastructure can. And in particular, when you deploy a contract, the contract management native contract looks for the deploy method, and if it finds one, it invokes it. And you can pass additional data to it, which we don't do in any of the samples we have today. But I've got other examples that do show that the Neo ID contracts actually accept data that's deployed, passed in at deployment time. And all this is doing is some very simple stuff where it's going to grab the transaction, the script container, cast it to a transaction, and it's going to put the sender of the transaction into storage as the current owner. One of the things we saw with a lot of Neo legacy contracts is that you'd have to actually embed the contract owner as like a hard-coded value in the contract, which of course makes it difficult or impossible to modify. So we here what we do is we actually just are using the sender, whoever's the deployer of the contract, whoever's the person who does the contract deployment is marked as the owner. Now, of course, if you wanted to do something more complicated, like support multiple owners or whatever, you could do that. But this is just a baseline that we make sure is available in every C# contract that we create. There's also a method called update. So as you can see here, update is going to call a method called contract update, and I'm going to pass it the contract file, the NEF, the Neo execution format. That's what NEF stands for, I believe. And the contract manifest as a string. It's a JSON file. If you've ever compiled a contract, like if we look here in this contract, I've already compiled it once. You can see here that there's 3 files that are generated: the NEF file itself, the debug info, and the manifest. And the NEF and the manifest have to get deployed. And in fact, you can see here, if we just format this, that this is just a JSON file, and it has information about the various methods that are in the contract, and including there's the deploy method. So before you can actually, so this is the method you call if you want to update. So if you want to make a change to your contract, you have to call the update method, but it means you have to actually have an update method for you to be able to call. You cannot call contract management update from the outside. You have to have your own update method. So again, this is part of the reason why we have it included in the basic template. And if you wanted to do something more complicated, you could, but this is at least the basics that you need. You can also delete, by the way. Contract management also has a method called delete, but we don't actually include that in the basic template. We don't expect developers to delete contracts. And if they wanted to add a delete method, they could. You could even, of course, obviously imagine a scenario where if you wanted to delete your contract and you hadn't already done a delete method, you could update to add a delete method and then delete. So that's why you have to have update from the beginning, but delete you can add later. And then finally, we have a code that's going to actually validate that the contract owner is making the call. Only the contract owner can update the contract. So we go and we get the current contract owner out of storage. We check that against the person who's invoking the transaction that to do the update, and we call the check witness function in order to make sure that the signature validates. So this is just a basic contract that you get when you this is going to be when you say new .NET when you say new C# contract in the 3.2 version of the tools, Blockchain Toolkit or .NET New. This is exactly what you're going to get, modulo the namespace and the class names. I also want to point out something that is coming new in the 3.2 release. If you've ever looked at the project file before, I realize that not all devs look at the project file. MS Build is a little bit of a black magic, in my opinion. But we've done a lot of work to simplify this. As you can see here, this is a dramatically simpler file than we've ever had in the past. And the reason for that is we've actually added new build tasks for running Neo Express and for running the Neo C# compiler. So you just include a package reference the same way as you would reference any NuGet package, except it's marked as private assets all. What this basically means is it's used during build, but it isn't actually connected to your actual code that gets generated. So your code can't depend on anything in build tasks, but your build process can. And we actually have already wired up a couple of properties so that will drive the generation project. So if you have a property called Neo contract name, which here you can see I've just set to the existing property assembly name, it will generate a contract. If you have one, so that does all the work to trigger running the Neo C# compiler. It also does the work to determine whether or not the compiler is installed locally in the project or globally on your system, and it does, which the old system did not do. So not only is it simpler, it's also more powerful. There's also, as you can see, it's commented out here, the ability to actually invoke the express batch file during build. One of the key things that key philosophies we have at NGD Enterprise is that we want to make sure that you can get your blockchain set up the way you want. In other blockchains, if you set up a test infrastructure, it'll create like 10 contract owners. I mean, it'll create like 10 accounts, and us will have 100 and Bob will have 100 and whatever. And that's great if that's what you need, but we want to make it really easy for people to be able to set it up exactly the way they want. And as part of that is we've made this batch process very fast. You can actually completely reset your blockchain during the build process. And we'll see that as we look at the second one, but there's not one that gets set up by default. I have also created a Neo Express file. Right, so this is just the normal kind of Neo Express file that you get. I've created a couple of wallets. I like to use Owen as the owner of the contract, and then you can see I've created a wallet for myself. We're not really going to do anything with this, but I just want to demonstrate that this was in here. I haven't actually created a batch file, but as I said, we'll see that in the next sample. And then it becomes really easy. I've also got, again, this is something I've added for this specific project. I've got, because we're doing all this work with Visual Studio Code, we also have set up a launch and a tasks file. So this way, this is how I can actually kick off the build. So if I go up here, this tasks file, you'll notice is marked in the group build. So if I go up here and I say to terminal and I say I want to run a build task, you can see down here that it's actually building. And this is the build output. You'll notice here, by the way, that if we open this up a little bit, we can see, let's close that. Yes, thank you. So as part of the build process, it does a normal C# compile, and then it's going to go and it's going to look for the Neo C# compiler. So it's looking for a local tool. I, on this machine, have not installed it as a local tool, so it's found a global tool. It's running the tool, so you can see how I'm actually specifying the contract name, the debug. So it'll generate the debug information. This is a debug build, so I do not do any optimization or inlining. And we can see here that it's created the various files that the compiler outputs, the devlog, NEF, manifest, and the debug information, and that it completed successfully. And so all that information is now here in this file. And then the launch file allows me to specify a configuration that I can actually run in the debugger. This example here is invoking the deploy method. So one of the ways that you can configure the debugger is to test out deployment. So if I actually, because I've set up the invocation as deploy, and when you do a deploy, there's no additional information. We need to make an update here, but if I run the deploy method, it comes up here. Yep, here we go. We can see here that we can actually step directly through the deploy code. So we can see storage, like so, for example, right now there's nothing in storage. Let me just close these down. If I step through and I do a storage put, that storage operation does get created. If you were at my last devlog, you know that we're working on a new, very significant update to the debugger and the developer tools to have a much better storage experience, but that is still in preview. That will still be in preview when we ship Neo 3.2. We will ship an update to the preview for Neo 3.2. That will not ship until after the Polaris hackathon, but you can use the preview during the hackathon if you want. There's instructions, and of course, I'm always available via Twitter and Discord to ask questions of whenever you want. So I'd be able to help you out with those things. So now this contract does nothing, right? It doesn't have any public methods that I can call other than update. And so I was going to show you real quick how easy it is to create a fungible token, right? Obviously, one of the things that people do with blockchains is create their own tokens. And I just wanted to show you just how simple it is to create a fungible token with Neo and C#. So if you're not familiar, there's a standard in the Neo space called NEP17. This is the fungible token specification. So I'm going to change, and instead of inheriting from smart contract, I'm going to change this code to inherit from NEP17 token. You also notice that there's a NEP11 token. That's the non-fungible token standard. That's a little bit more effort, so we're not going to do that here this morning. I have a sample that I delivered last year for the mainnet hackathon, the Frontier, I believe that one was called, that uses the NEP11 token, and you can see that. There's other people who've got samples in this space as well. But we're going to do a NEP17 token. So I'm just going to change that. I'm going to give it a second. You'll notice here that it gives me an error. I've got this nice little Visual Studio Code extension that will actually surface these IntelliSense errors directly inside of my code. So I can see here that the devlog token does not implement inherited abstract members. So I'm going to, I don't know if there's I know I do this with the control period, and I'm going to bring up the refactoring, and you'll notice that one of the options is to implement a abstract class. So here we are. We're going to do the massive amount of work it takes to turn our baseline contract into a NEP17 contract. Okay, we're done. That was all it took. So it generated the code for two methods. It does kind of put them in alphabetical order, which I don't particularly like. I want them at the top. There are two methods that the NEP17 token does not already implement. If I go here and I click on it, I can go to the type definition. I can go to the definition. I guess I will have to bring up the code for it. 1 second. So this is the official DevPack repo, the official Neo DevPack repo. And it has the code for the smart contract framework. And we can see in here that there's a type called NEP17 token. And if we look in here, we don't need this. We can see here that it has implemented all of the various pieces of the NEP17 contract. So there's the transfer method. It has the transfer delegate. We're going to talk a little bit more about how this stuff all works in a minute when we look how to build this stuff yourself when we look at the next contract. Here's a mint and burn function. These are protected, so your contract can call them, but they can't be called from the outside. This contract actually inherits from token contract, which is a base class that also implements information that is common to both NEP11 and NEP17 contracts. In fact, you'll notice there's the symbol and the decimals function. These are marked as abstract. So that means you have to implement them yourself. And as we saw that when we opened the contract and we said implement the abstract methods. It implements total supply, balance of, et cetera, et cetera. So almost everything is already implemented for you. The only two things you really have to do with your contract, now I'm going to go back to my code here. The only thing you have to do is you have to implement a symbol. So like, let's say, return devlog token or something like that, right? And I need to give it a number of decimals. For those of you who are not familiar, one of the things about blockchains in general is they typically do not use floating point math. They use integer math because in order for code to be deterministic, to run exactly the same on every consensus node, on every other verification node in the entire chain, that usually does not mean that you can use floating point math. Deterministic floating point math is not really a thing. So everything is done with integer math. But you can, for tokens like gas, which are in fact divisible, right? Neo is indivisible as a token. Neo, the token, not Neo, the blockchain. But gas, the token, is divisible up to 8 decimal points. So there's a decimals method for gas, and it returns the value 8. So we'll just do the same thing here. And then the only other thing we need to do is we actually need to mint some tokens, right? Now that we've created this, that's literally all you need to do in order to be able to create a NEP17 token. Pick a symbol and figure out how divisible it is, how many decimal points worth of divisibility there are. The only other thing you need to do is to actually mint some. You can imagine that you would maybe want to do some of this with this passed in data function, but for all I'm going to do right now is I'm going to call that mint function, and you'll notice it comes right up here in IntelliSense. I can't call it from the outside, but I can call it from the inside. And I'm going to just mint, and I'm going to send this to the transaction sender, the same owner of the contract, and I'll create, say, I don't know, 10 million. So with essentially 3 lines of code, right? I added this line, and this line, and changing the base class from smart contract to NEP17 token. I've created my own token that I could go off and deploy on testnet or mainnet like any other token, etc. This standard, this NEP17 standard, is the exact same standard that Neo and Gas are implemented with. So the same exact things you can do with Neo and the same things you can do with Gas, you could now do with Devlog token. So it's really simple, and I just wanted to be able to demonstrate that how simple it is to get started with building your own token on the Neo platform. So now the thing is that it's so simple, it actually makes for a really bad developer demo. Like I don't have to do anything except for track the owner of the contract. So I'm going to use a different demo from the rest of for the last 40 minutes of this presentation. This presentation, let me just save this work. So this other sample that I'm going to show you is actually an escrow contract. And so this was actually originally written by Halo 9000, Joe Stewart. He is a fantastic member of the Neo community, and I'd like to thank him for, he actually helped me a couple of years ago when I originally ported this code from Python to C# during Neo Legacy, and then I brought that forward to Neo N3 with this code base. This is available on my GitHub repo. So if you see here, let me just bring up the page here. You can see it's github.com devhawks safe purchase sample, and I'll drop this into the devlog after the talk. I will drop that into the chat so that people can have access to it. So this contract it's obviously still a sample, but it is designed to be a production quality sample, a real world scenario. And so the scenario of this contract is, as I mentioned, is escrow. So there are 2 parties that are involved in this scenario, the seller and the buyer. And the seller is going to create a sale, and they're going to put something on sale for some amount of some token. In the demos we walk through it, it's going to be Neo tokens, but it doesn't have to be Neo. Like if I wanted to sell something for 1,000 devlog tokens, I could choose to do that. That's up to the seller. When the seller creates a sale, they specify what kind of token they want to support. So if they want to sell it and get Neo, they want to sell it and get Gas, or get some third-party token, it's entirely up to them. When they offer something up for sale, they have to provide an equal number of tokens. So in this example, what we're going to see here, I'm going to bring up the invoke file for create sale. You can see here, by the way, this is the Neo N3 visual dev tracker. This is the invoke file editor. Right? So if we actually look here underneath, we can see that this is just a JSON file, right? And the other view of it we just saw is the rich editor for it. I'm going to leave it in the JSON file because it's a little bit easier to see in this context because we're actually providing information. This actually is a contract invocation of the Neo token contract. So when you actually create a sale, you're not actually calling a operation on, you're not actually creating an operation on, you're not calling an operation, excuse me, on the contract that I'm writing. I'm actually invoking a token contract. And in this specific example, I'm creating a Neo token. I'm going to be selling my widget here. Obviously it's just a widget. It's, I'm not really selling, this is just a demo. I'm going to sell this for, I'm going to sell it for 50 Neo. But you'll notice that I'm actually providing it 100 Neo. The way that this specific contract works, and that's just the business logic of HAL 9000's original contract, and I thought it was pretty good, so I just stuck with it. The way that this works is the seller will put an item up for sale, and they will deposit twice the sale value in that token. The buyer then does the same, And then in the real world, the seller sends the item to the buyer. And then once both sides have confirmed, the contract releases the original deposit by the seller and half of the deposit by the buyer to the seller, right? So the seller will get, in this case, 150 tokens, and the buyer will get 50 tokens back. And the idea there being that since twice the value of the item is essentially locked up by the contract, it acts as an incentive for the participants in the sale to complete the sale successfully and correctly at the end. I would imagine that in a real world version of this contract, you'd have to have some sort of ownership mechanism where the contract owner would be able to litigate other types of issues between the seller and the buyer. Once the contract has started, there's not really a way to cancel it and go back. And so there's some things that could still be done to this contract to make it ready for the real world. But it's a really good example. And as I said, HAL 9000 did a great job with the original contract. And so I love using this sample. You'll notice, by the way, that I'm passing in, I'm using a variety of shortcuts that have to do with Neo Express, right? So I'm using the contract, I'm able to specify it by name, right? I don't have to specify it by its contract hash. Neo Express and the debugger know how to parse these files and treat them. Well, obviously Neo Token's built in, so it just can tell that automatically. I'm calling the transfer function. I'm going to use @seller, so this sort of like Twitter kind of @ and hashtag basically are used to indicate, like if we go and we look in the Neo Express file, we scroll down to the wallet section, you'll notice that I have a contract owner, a contract seller, and a contract buyer. Or, I mean, not a contract seller and buyer, but a wallet account for seller and buyer. So in this specific example, I didn't want Alice and Bill and Charlie. I wanted buyer and seller. So I was making it very clear which each of the owners are. And I've been able to set this up exactly the way that I want. And in fact, if we look here at the Express batch file, right? So if we go back, I'm going to point out real quick, you'll notice here, oh, that's the test file. That's not the one I wanted, excuse me. So this looks very similar. This is just like this is almost identical to the project file we looked at before. There's only two real differences. First off, we've uncommented the Neo Express batch file. So the fact that there's a property called Neo Express batch file will run Neo batch file during the build process. You also notice I don't actually have the build tools here. I've actually, in this specific example, pulled those up because I also have a test project. So I have a top level build property here where I've specified the Neo test packages version. You'll notice that I'm running a preview version. And I have the build tasks that are available. The build tasks are used by both the test and the source project. So I have it in this top level build project, this top level props file, so that way I can use it in both places. And I'm specifying the versions once, so that way I don't have to. That way, when a new version comes out, because at some point we will ship the non-preview version of the 3.2 Neo test package. I'll just be able to say, oh, I'm just going to, delete that, and it'll automatically pick up that specific version, and it'll flow through all the different build files. So in here we have in the safe purchase contract. I just want to go through the code, and then we can actually see this running in the debugger and some other examples. So before we get any further started, I want to point out that you'll notice that there's a contracts owner prefix, right? So we actually are storing, where the last example, all of the additional storage of the contract, the original project only managed the contract owner. And then when we changed it to a NEP17, there was more data that it was storing, but it was all implemented by base classes. Here, we actually we're going to track sales and account sales. And we'll talk about the specifics of what the difference is between those two in a few minutes. And we have a contract owner. And in fact, if we scroll down to the bottom, because I like to have this stuff at the bottom, look, there's the deploy method, just like we saw before. There's update and there's validate contract owner. One of the nice things, by the way, about having validate contract owner broken out like this is you can imagine there might be other scenarios. As I mentioned earlier, you might imagine having a escrow contract that also allowed some party to act as a mitigator or an independent third party to adjudicate a complaint during the process. Like if the buyer doesn't receive what the seller, if the buyer never receives what the seller was selling because it was lost in the mail, or if the seller has sent something and has misconstrued what the item really is, or something like that. You might imagine a scenario where you would want to have some type of party be an independent third party to be able to adjudicate these kinds of processes, and the contract owner would be an obvious choice for that. And so here we can very easily use this same logic in other pieces of code to say, oh, is the contract owner the one who submitted this contract? So I just wanted to point out that that's the exact same code as we saw from the template earlier. So now if we go up to the top, you'll notice, hold on, sorry, I had turned off all notifications on my phone. I guess I did not. So if we go up back to the top, there's a couple of different things that I want to show in this code. So first off, we'll see these. This is the way I like to structure a C# contract project. So at the top, I like to put all of the prefixes that I'm going to use for storage maps. This contract is going to store information about sales and the sales that are currently in process. And so I'm going to have that's what these top two prefixes are for, plus the bottom one is the contract owner, which we talked about earlier. And then we have a series of delegates. Delegates are used for notification. Every time you invoke a contract, every time you submit a new transaction, right? So in Neo, you can invoke a contract to get data, and you can invoke a contract to make changes. If you invoke a contract to get data, it does not, in fact, modify the state of the blockchain. And in fact, you'll notice down here, this attribute called safe. A method that is marked as safe cannot make changes to the underlying blockchain database. It's just the permissions are disabled. So even if you try to, the underlying platform will disable it. And so this is you tend to end up with Neo contracts that have like a set of safe methods which are used to get data out. Like if you think of a balance of or tokens of and standard standard fungible and non-fungible tokens, those types of examples are cases where you want to actually get data that's currently stored inside the contract. Another thing that also happens oftentimes is there are alerts that are raised. So when you submit a contract, when you submit a transaction to invoke a contract that makes a change, it can actually raise an alert, and you can actually get this alert information via the application log, right? In fact, like so, for example, if I go and I run my well, we'll see this in a little bit, but I like to the way notifications are done in C# is they're mapped to events. So if you call an event in your C# code, that will raise a notification in the app log. And for I like to define my own delegates. You can use C# defines a set of generic action delegates that you can use. But the thing I like about using these, and that way you get the right type. So I could say, like, for example, instead of on sale completed, I could just say action byte string. But one of the things that's really nice about this is I actually get the name of the parameters. So I understand what it actually means. And that information ends up in the manifest. So by actually having that information, if you use the generic, it's just like parameter 1, parameter 2, whatever. And so that can be really valuable. Like, for example, here you can see, like in new sale, I'm specifying a uint as the seller. For sale updated, I'm specifying the buyer. So like, it's nice to be able to later see, oh, what does that actually represent? This uint represents the seller. This one represents the buyer. This represents the token. As I said earlier, the seller has the choice of how they want to actually specify how they want to get paid. I want to get paid in Neo. I want to get paid in gas. I want to get paid in some other token. So the way this process kicks off is via a payment. So one of the things I really like about this demo, about this specific contract sample, is it demonstrates how to interact with the payment infrastructure of Neo. So when I go to make a contract call, when I go to create a sale, I showed this earlier, I'm going to call the Neo token. I'm going to transfer a set of tokens, in this case, 100 tokens, into the Neo contract. And I'm going to provide it a bunch of data. And you'll notice that this data is just in JSON, right? So I'm passing it a set of additional information. I'm calling it the name of the method I'm going to call in the safe purchase contract. So I'm transferring from the seller to the safe purchase contract 100 Neo. Of course, this is all running on Neo Express, so it's not real Neo. And I'm going to then have this additional information that gets passed to the method implemented by the contract. So this is a way that I can tell that information flows from the Neo token contract into my contract, so that it can tell, hey, that's what this transfer is about, right? And you'll notice later we'll do the same thing for the buyer, but we'll pass in different data. So if we look in the contract, you'll notice that we have an on NEP 17 payment. So this is a standard format method that you can implement on your contract, that you must implement on your contract if you take payments, right? So this is automatically called by the platform when you accept a payment. And you'll notice that it takes a from, who sent the payment, how much is the payment, and then you'll notice that I have this object array. And that is essentially this array here. Now let's make this so I don't have to keep opening and closing these files. This array here is this. Now, of course, this can be any type of Neo parameter. So it doesn't have to be an array. It could also be a map. It could just be a single integer or a string or whatever. But in this specific case, I needed 4 pieces of information, right? I need to know this is a sale creation. I need to know how much I'm selling the item for. I need to know its description. And in this specific case, I need an ID. Now, this is another thing that's actually sort of an interesting point. Oftentimes, it's useful to create IDs inside your contract, right? Like I'm going to hash the description and the seller together and maybe the nonce of the block where it was created. And I'm going to use that to create some kind of ID for this sale. And the problem with that is that while that's a really good process for on the main blockchain, it's very hard to debug and develop, right? Because obviously, as you can imagine, that ID, you can see here 1ADE, well, the buyer is going to have to specify that same 1ADE. And when I go to confirm receipt, there's a 1ADE. So that information is embedded in every single one of my invoke files. So it would be very convenient if I knew what it was going to be ahead of time. So for this specific contract, I've made it specify that you can actually, if you choose, you can specify the ID directly. If you do choose not to, it will automatically create one for you. And so then inside my NEP 17 payment, I do some basic parameter validation. So I make sure that there's a from. It turns out there's also you'll actually get called twice. You'll also get called for gas. So if there's no from, right, because there's a transfer of gas that occurs officially when you make these kind of invocations. So if there's no seller and we're talking about a gas, that's just a Neo balance change. We can ignore this for the purposes of buying and selling. It's not obviously used in that kind of context. You can still sell your item for gas, but in that case, the from won't be null. It will be an actual value. So then we check to make sure there's an actual from value, there's an actual data value. The data value is an array of the right length. If the command is sale, all right, and you'll notice here we're looking for the name create sale. All right, we saw that in the invoke file. I check to see whether or not the length is not 3 or 4, right? So again, if the length is 3, then the first value is the price, the second value is the description. Of course, the very first value is the name, right? We're grabbing that here, right? And we use that to drive this if-else tree. So if it's create sale or buyer deposit, those are the only transfer operations this contract supports. Otherwise, it'll throw an exception. By the way, it's really important to throw an exception here because throwing an exception will automatically roll back the payment. If you just say return false or something, then the payment won't actually be rolled back. So it's really important in these types of scenarios, especially with transfers, to throw when you have a scenario where you want to make sure that the payment does not complete. So here, all I'm doing is I'm then parsing out that array, right? So I'm grabbing the price, I'm grabbing the description, and I'm looking to see whether there's a sale ID. Did the user provide a sale ID in the array, or did they not? And in which case, I'll generate my own. And then I call the create sale function. If you did any Neo legacy code, this kind of like checking the name of the operation and manually dispatching was a very common approach. And we've gotten rid of that in Neo legacy for main operations. But for these types of transfer operations, you do have to do something similar. You'll notice, by the way, we'll get to it later, there's also the buyer deposit. So if the buyer deposit, I'm going to get the sale ID from that object array, and then I'm going to call the buyer deposit function. But we'll look at that in more detail later. So here we are in create sale, and then create sale. This is just sort of standard kind of Neo blockchain business logic. As I said, originally written in Python. You'll notice that I have the identity of the seller, the amount. You'll notice that I have both the amount and the price, right? So the amount is how much Neo or how many tokens were actually transferred to this specific contract, and the price is how much it's being listed for. And you'll notice that one of the first things that we do is we check to make sure that those two sync up, that the amount is the price times 2. That's the rule. If you do not deposit twice as much as you're selling it for, the contract will throw, and that transfer will automatically roll back. So again, it's very important in these types of payment scenarios to throw exceptions in scenarios where you want to make sure the payment doesn't apply. And so if you've failed to create a sale, I want to give you your money back. And then we take the script hash of the token. This will tell us what, because of the fact that we started by invoking the token contract, this is how we know which actual token it is. So this could be the gas token or the NEO token or something like that. You can also imagine at this point also doing things like validating that it implements an F17 standard and what have you, but we haven't done that here. So if the sale ID is not null, then it has to be 16 bits. This is it's just a way that I specified this. We're going to do this. It's a way of being able to differentiate between the system generated hashes and the ones that are provided from the outside. And again, you could imagine having a different mechanism here. I like to actually call out, if you guys know Robert Oshler, I'm mispronouncing his name, GPT for me. He actually has a really interesting, he was showing me an example where he actually checks to see if the contract is actually running on Neo Express or not. So of course, every time you create a Neo Express contract, I'll come back to this here in a minute, it has a magic number, a network number. It was called Magic and Neo Legacy. We've never updated the file format. It generates this randomly. And it specifically checks to make sure that the magic number that's chosen for a Neo contract or Neo Express blockchain does not match any of the relatively known ones like Neo N3, Neo Legacy Mainnet, Neo Testnet, etc. So he actually uses that information to determine, hey, am I running on Neo Express or am I running on Mainnet or Testnet? And he actually changes his logic based on that, which I actually thought was another interesting way to tackle this. Like you can have in a scenario where I have a deterministic way of generating the sale. You'll notice here that the non-deterministic way takes the seller, the price, the description, and it uses the random number value from the runtime and generates a hash. So this is a deterministic random number generator that the platform provides. So this is completely, it's deterministic from the perspective of the blockchain of the contract. Right, every single node running this specific contract at this specific height will get the same value, but it won't. But it's really hard to know what it's going to be ahead of time when you invoke the contract because it's going to depend on what the block height is. So this is great for production, but it's really hard for development. So I took one approach, which is this: I'm going to pass the ID in manually. But a completely different approach might be to say, I'm going to have a deterministic way of generating this. I believe in Robert's contract, he just uses a number, right? 1, 2, 3, if he's running on Neo Express, which is, of course, very developer friendly. This long hash might be deterministic and static from a developer perspective, but it's obviously not as easy to work with as, like, say, the number 2. Anyway, so the contract logic here is pretty straightforward, right? As I said, so I'm doing some validation. I'm generating the sale hash, and then I'm creating a storage map, and I go to check to make sure the sale doesn't already exist. Again, more validation. And then I just save it. I create a sale info object. I put the contract, I serialize that value into a byte string so that I can save it to the sales map. I'm also keeping track of a what's called an account map. So this is actually, if you've worked at all with the NEP 11 standard, this is a very common format. This is a way of, so the real list of contract sales, the real list of sales is stored in this sales map, right? So I've serialized all the information about the sale. You'll notice, by the way, that I've got the seller, the description, the price, the token, the sale info. If we look up here at the top, is just this class. It has a seller, a buyer, a description, a token, a price, and a state. And the state is this enum. So the state can be new, like I've created the sale, but nobody's bought it, awaiting shipment, and shipment confirmed. So there's this process that the sale will go through. It will start in the sale state, move through the awaiting shipment, move to the shipment confirmed. And then the final statement is a shipment received, receipt confirmed, in which case the contract, the sale completes and it gets deleted. So when we go to create the contract originally, you'll notice that we, create sale. We set the seller. The buyer is not set because we don't have a buyer yet. We just set the description, the price, and the token. And then we set the state. It starts in the state new. We take this information, we serialize it out, and it gets put into storage. And then we also have this account sales. Now, I don't actually have a method for this yet, but the whole point of this is to be able to say, I want to be able to list all of this. I'm sorry, I do have a method for this. I take that back. I want to be able to get a list of all of the sales a given seller has. And so in order to be able to do that, I need to be able to have some kind of index to indicate this sale goes with this seller. I don't want to have to go through and look at every single sale. You can imagine if I've got hundreds of sales and one seller is selling one item, I don't want to have to go through and pay the gas cost to deserialize every single sale just to be able to find the ones that a given seller is selling. So that's what this account map is for. So I'm storing the key for this. I'm storing, of course, the prefix, and then I'm storing the seller's account information, their UINT 160, their address, and then the sale ID, which could be a 16 or a 32-bit value. And then I mentioned I do the on sale operation. So that's this event here at the top, which we saw before. The on sale delegate. That's information that gets put into the event log, so that way code from outside can see, or logic from outside can see, that a sale was created. This is very common to do in contracts. You see this a lot, for example, with there's a transfer event that occurs in token contracts, NEP 11 and NEP 17, that gets fired. So we use that here in this safe function. We're not going to go through. We're almost, we've only got about 10 minutes left. I want to leave some time for questions. So I just want to walk through the sales method here. This is a way that I want to be able to get all of the sales that are associated with a given seller, right? And that's where we're going to use that account map. So here, this is a safe method. It's not making any changes. It's going to return a value. It's going to return a map of byte string to object. Down the road, I'm planning on modifying this so that it will actually return a map of, because here what it's doing is it's actually converting the map. Byte string is the array, is the sale ID, and then this secondary map is a collection of information about the sale. So you can see here we're just getting seller, buyer, description. But especially once we get to the new debug info that we talked about in the preview from my last devlog, it'll actually be easier just to say, I'm going to return this as a sale item, right? This sale struct, this sale info struct. And then all that information about what this option looks like is in the debugger, is in the debug info. So we can actually deserialize it in the debugger and see what it looks like, as opposed to having it converted into this name value map. But that's the way the code was originally written, and it hasn't been updated yet for the new preview. So we do some quick validation, make sure the seller is a valid value. I create an account map and a sales map, and then I'm going to create an iterator where I walk through the list of I'm going to use that account map, and I'm going to set as I'm going to create the original storage map, uses the account sales prefix, and then I'm going to use the find method to find all of the ones that start with seller. Again, this is after so they're going to be prefixed with this account sales byte and then the seller's address. I only care about the keys because the value it's just an index, so the value isn't important. And I want to remove the prefix. What that means is that all that's left is the sale ID. So this allows me to iterate through just the items that this specific seller has on sale. And then I can go off and get that actual value from the sales map, deserialize it into an object, and then change it into a map and return it. So let's actually see what this code looks like running under the debugger. So we're going to start by building it. So I'm going to open this up here a little bit. I'm actually going to clean just because I want to make sure that it's going to do a complete build first, because I want to show you the whole process. So this build process is going to build the project contract. It's going to run Neo Express to deploy the contract and set it up the way it needs. It's also going to build the tests. I'm not going to actually run the tests, but it is going to build them. I just wanted you to see how fast this is. Remember, I'm modifying the contract. So I've already contract modified. That was all it took. So it took almost about 6.5 seconds, and it built the contract. Here it is generating the NEF file. And it also then runs the batch file where I'm actually doing a series of transfer operations, a deployment. I'm actually working through the entire process of a full sale. We look here in the batch file, you'll notice here we're setting up transfers where we transfer some gas and Neo from Genesis to the three the three accounts in this scenario: the contract owner, the buyer of the item, and the seller of the item. We deploy the contract, we invoke the contract to create the sale. We invoke the sale for the buyer to make their deposit. The seller does their confirmed shipment, and the buyer confirms receipt. We're also creating a checkpoint for every single one of those. So we look in the checkpoint folder, you'll notice that we have 5 checkpoints that have been created. We can use these checkpoints for test purposes, for debug purposes. In fact, if you look here in the test folder, we're not going to go through the tests in great detail, but you'll notice that I have a test, for example, that uses the contract deployed checkpoint to ensure that the contract owner is there and that the seller has 10,000 Neo, which isn't really a scenario of the project, but is important from the representation of making sure that everything else is set up correctly. I'm expecting there to be 10,000 Neo in the seller's account, so I want to make sure that that's correct so that all of my stuff has worked correctly. And then in my sale created tests, I've created the seller has, when I've done this transfer, they have 9,900 Neo left, and that there's at least one sale listed. In fact, you can see here, and eventually this code will be updated so that it will automatically, be able to validate the actual sale was created correctly. But you can just sort of see I use these tests. I can actually create these checkpoints during the build process so that I can then run them during the tests. So by using this checkpoint path, this class fixture interface, and this is a unit test framework called XUnit that is very popular in the C# space. I can actually get this information, and I've written a bunch of the test framework has a bunch of code to be able to automatically get a chain so that you can actually run this type of operation directly in your tests against a test instance of the application engine using real data from the checkpoint. But let's see it run in the debugger because that's more fun. So I'm going to run the create sale. If we look in the launch file, you'll notice that the create sale is using the invoke file create sale, which is convenient because now I'm using the same invoke file for debugging. I'm using the same invoke file for my batch file. Right here it is, same place here. So that way I only have to change it in one place. If I want to make a change to my code, I can change the invoke file one place, automatically updates the debug scenario, automatically updates the batch scenario, etc. I'm going to use the contract deployed checkpoint, right? So this is the idea that I've deployed the contract, but I haven't actually invoked it to create the sale. So otherwise I've specified all the information I need here. Where's the path in Neo Express file, so I can do things like @seller instead of having to specify a full address name. That's the signer of the contract, which of course turns out to be a relatively big deal in this scenario. And now I'm going to walk through create sale. Now you'll notice that it's actually trying to do a rebuild, but it's actually not rebuilding, right? You'll notice, like, if we go back to that terminal window, all those steps around configuring Neo Express, it was able to determine that it didn't actually need to update the contract at all. The contract was already available. Neo Express had already been run. It didn't actually have to change anything. So it goes through and verifies, but it doesn't actually take those steps to actually run the to do the compiling if you don't have to. Anyway, so you'll notice that it's stepped directly into this on NEP17 payment. So I've invoked the the Neo contract, and the Neo contract is then called into my code. And I can see right from here that I have a from and about. It'll be much nicer once we actually have we have the information here, and this object, this data is an array. We can see that that's correct, and we can then just step through the code. And so, we step through here. We can check here to make sure command equals create sale. And then once we've gotten into that, we call into the create sale function. And we do, again, we walked through this code before, so I'm not going to get into too much detail. You can see here that it's checking to make sure the sale ID is the correct length because I've actually specified that. It serializes everything out. If we look here in storage, we'll notice there's one value in storage right now. That's the contract owner, which is specified on deploy. And as we go through in here and we say put, we'll see a second storage show up and then a third storage show up when the account map gets set. So we now have all three of those specified in the in storage. And then the other thing is when we then call new sale, one thing I want to show here is if we look in the debug console, you'll notice, by the way, here's the gas token transfer. I mentioned that there's a standard gas token transfer that gets occurred. It had a null value, so we ignored it. And then the Neo token transfer, this is where the seller's, this is the seller's address. This is the address of the contract, and this is the amount 100. So as we then call on new sale, we also get that same information. We're creating another notification. So if you were to look in the application log for this specific contract invocation, you would see these two transfers and this new sale notification, which you could then operate on from the outside if you so chose. And then that's it. And then we can see, we'll go here and we'll look at sales, and we'll do that one as well. And again, it's going to build, but again, it's running through the build process, but MS Build and the extensions that we've built for it are smart enough not to rebuild the contract and not to rebuild the blockchain if it already exists. And so then we can step through and see, okay, we're going to create the account map, we're going to create the sales map, and then we're going to iterate through each individual sale. And you'll notice here that the sale ID, as we step through, is, look, it's a 16-bit byte string. That's the ID. So we can then say, okay, great, I'm going to use that. I'm going to deserialize this into an actual sale info object. Because we're not running the preview, we get all this sort of raw information as opposed to the nicely strongly typed version, which we'll get after we update to the preview version. And it just adds that to a map. There's only the one sale, and it returns it, which then gets debunked, sent out to the debug console. So you can see here that invoking this contract had a gas consumed, and it returned a. This is how a map is represented in it's represented as a sort of as a JSON object. So you can see here that the top level map is the seller, is the sale ID. There's that 1ADE again. It's in all caps, but that's the same value. And then it's returning another sale value, which is another map, which has seller, buyer, et cetera, et cetera. Now, we're obviously running out of time here, so I'm not going to be able to walk through the rest of the scenario. But as I mentioned, this demo is available here on Safe Purchase. The version that's in master, it is here. So this is in a little bit of a weird state. It'll be ready for complete, just clone and test once 3.2 ships, because then we'll also have the updated build tools and what have you. So it's a little bit of a wonky shape right now, but it will be most of the code is there, and you'll be able to use this for your own testing and example. Use it as a demo for your own purposes once 3.2 ships. So with that, I see that it's almost 8 o'clock. So I don't know if we have questions, Sam. Is Sam still on? Yes. I don't know if anybody. I don't know how we do Sam questions at this point, Sam.
Thanks for Harry's presentation. So audience, if you have any questions, you can write down in the devlog test channel. Harry will answer it.
Yep. And look, obviously we're recording this, so if you're watching this on video, and I'm not currently, I'm not live, I'm on Discord and Twitter a lot. I actually dedicate a very significant percentage of my time during hackathons like this to answer questions for developers. Somebody asked me one time during the Frontier hackathon why I wasn't one of the judges. And I actually don't want to be a judge for the hackathon, because I want to be able to help developers like you build the best solutions possible on top of Neo. And I can't judge fairly if I'm helping people. And believe me, you'd much rather have me helping you than judging you. So let's, if you have any questions, please feel free to ask me anytime I've spent a significant percentage of my career as a consultant or as an evangelist, and so helping developers directly it's in my blood. So I'm a very big fan of it. So please feel free to ask me questions anytime now or in the future via Discord or Twitter or what have you.
Okay, very appreciate with Harris can help. And actually, personally, I have a question for you, Harry.
Sure.
I want to know what's the back logic of the update method of the smart contract. I mean, that's one of the important blockchain feature is immutable. If you can update a smart contract, did that means you change the previous states you deployed the smart contract you deployed before? That kind of not the blockchain features, in my opinion.
So this is one of those situations where Neo has gone through and taken a common pattern that occurs in blockchain development broadly and codified it in the underlying platform. If you think about, let's take your scenario where, and in fact, that's how contracts were in Neo Legacy, Sam. They were completely immutable. So once you deployed a contract, you couldn't ever change it. And what people are finding on blockchains in general is what they'll do is they'll deploy a contract and it'll have some hash, right? You deploy a contract, it has a hash. That's how you invoke the contract. But then they'll put a proxy contract in front of it. And that proxy contract will be the one that developers actually call. And that proxy contract will have some contract data that has a pointer to the actual real contract. So if you have that, then you're calling a contract, which is then going to look up some information in data storage to determine what contract you really should be calling. Okay. If you do that, you're defeating the whole purpose of using you're defeating the entire purpose of having a immutable contract, because you're no longer invoking a contract based on its contract hash. You're invoking the actual business logic is being invoked based on whatever happens to be in data storage. So what's nice about the way Neo has done this is that you can actually get the information about a contract. Like, in fact, if we look here, you'll notice that one of the things that I have, let's go down to the update method just for the sake of argument. You'll notice that there's this contract method update. If I say contract management, not contract method, excuse me, you'll notice that there's a method called get contract. So I can actually, if I have a hash, I can actually get the contract information, right? So let's just say, var c equals get contract. This is obviously not a real, I'm just using uint0 to get the thing to stop complaining. You'll notice that if I look at the contract value, you'll notice it has a bunch of information in here. In fact, let's see if I can do this. Will this work? Cool. So here's this is the contract management object in your contract. You'll notice that it has a contract. If you call the get contract function, you can get information about the contract. If I look at the definition here, you'll notice that it has a set of properties. It has an ID, that's its internal tracking number. It has a hash, that's the contract invocation. Here's the byte string that represents the actual deployed contract and the manifest. But check this out. It has an update counter. So when you update the contract, the platform automatically updates this. So if you look at say a competing blockchain where you have some proxy that's sitting in front of it, you have no way of being able to know whether that proxy has been updated. But here, if it's really important for you to make sure that you're invoking the correct version of the contract, you can actually get the contract information and check its update counter. So you can be absolutely guaranteed that you're invoking the correct version of the contract. And of course, this works for both contract to contract calls. This information is also available via the JSON RPC interface. So if you're going to invoke a contract on the outside, you can also be sure that the update counter is correct. This is important because now you're in a position where you can be sure that you're invoking the correct version of the contract and then bail out if it's not, right? If the contract's been updated, I'm not sure what the right business logic is. It's going to be very dependent on both the caller and the callee. But the platform, the Neo platform, provides you the mechanism to be able to guard against that as much as you feel that you need to, right? If you're just going to invoke it, obviously in the samples that we've shown here, we're not ever checking the update counter. But you could actually check that. You could even inject, if you're doing a contract invocation, you could even add a call to check to make sure that the update counter is correct before you actually do your invocation, right? When you actually invoke a contract on the Neo blockchain, you're passing it basically a script. So if you wanted to add to that script, hey, check the update counter, make sure that it's what I'm expecting it to be, you can totally do that. So it's a more advanced scenario, Sam, but it's a very powerful platform feature, in my opinion, because this pattern of allowing, putting proxies in front of contracts so that you can, in fact, change them in the future is a very common scenario on competing blockchains. But in that scenario, it's really hard to know if that has been changed. There's no way for you as the caller to be sure that it hasn't been changed. Neo, I don't think there's another blockchain platform out here who provides, there probably is, there are so many blockchain platforms, but certainly none of the mainstream ones that provide a mechanism like this, which allows for both update to the blockchain contract and for the caller to be able to validate that the contract hasn't been changed or it is the version that they're expecting it to be. That's a great question, by the way. Thanks a lot.
Okay, thanks. I think that's a lot of information I need to check and understand.
I think it's one of those things that it when you first hear about, wait a minute, you can update contracts, that doesn't make any sense. But then, as I said, when you actually see how contracts are deployed in the wild on blockchains that don't have this support, and you see what they do in order to work around it and the limitations of those workarounds, having the update built directly into the I had the exact same reaction you did, Sam, when I first saw that we supported update. I was like, that doesn't make any sense.
Yeah.
But once I actually sit down and dug into it and realized this is a platform that allows, because developers need to change code, right? It happens, right? You have bugs, you have errors, you want to add new features, right? That's just the way that things work, right? But having it baked into the platform provides the security to the caller that you just can't get if you're using a workaround on a competitive blockchain.
Okay, got it. Okay. I think that's
We're 10 minutes over. We're good at this point.
I think it's 3 past 8.
Yep.
Yeah. I think I don't see there are any other questions from the develop channel.
Yep.
So I think that's all the workshop. Any last word, Harry?
Nope. Just as a reminder, my handle is DevHawk, and I am available on Discord and Twitter a lot of the time, especially over the course of the next month while we are in the hacking part of the Polaris hackathon proper. So I'd be happy to answer questions and help you guys out with your code. I even review code in time to time.
Oh, I think there is another question pumping up. It's from Gravity. Doesn't it create a security vulnerability if the users update without their knowledge?
I'm not sure what you mean by users are updated. We were talking about contracts updated. And the point that I'm making is you can't update the contract without it being known that it's been updated. So this update counter is managed by the platform. So if I deploy a contract, the update counter will be 0. If I update it, it gets incremented to 1. If I update it again, it gets incremented to 2. So if you're calling my contract and you want to be guaranteed that it hasn't been updated, you can actually check this contract update counter before you do your invocation, right? You can do that in your calling contract. You can do that in the calling script when you're submitting a transaction or what have you. So if you want to check that, if it's important to you, then yeah. And it being updated without your knowledge, you can imagine a scenario where, I have some, like we were showing this escrow contract. If I updated it so that I started skimming 20% of the sales fees, you probably would like to know that, right? But you can imagine saying, before I actually invoke this contract, I'm going to check the update counter to make sure that it hasn't been updated. That's a platform feature that's just not very common in the blockchain space. So you have the ability to update, but because it's managed by the platform as opposed to implemented by these sort of contract workarounds that other blockchains use, you as the developer, as the caller, can actually have some level of safety. And I see you've added a follow-up question about it being a little bit difficult for end users to keep track of. And it is a little bit difficult for end users to keep track of, but it's possible, right? On other blockchains, if you use a workaround, it's impossible, right? So I would rather take difficult and possible over impossible. That's, if you don't support a mechanism for updates, what will likely happen is that you end up with a model where people will deploy their main contract in sort of a hidden way, and then a proxy contract that sits in front of it, and that will do the redirection to the correct version of the contract. And as I said, with that kind of scenario, you have no way of knowing you have no way of guaranteeing which version of the contract you're actually getting.
Okay.
I will say it could be easier in the code to do that verification. Like we could have better samples and maybe even some like helper classes that do things like, I want to invoke this contract, but I want to make sure that it's at least this version. Like that could be like that. We could make it easier, right? And that's the place where I come in, right? I mean, I don't, I'm a core dev on Neo, but I don't spend much time working on the core platform. I work on the developer tool space. So that's a great feedback, and we'll take it into account. We'll take a look at what we can do to make that easier, so that it isn't quite so difficult. So when I go to invoke a contract, either from the outside with JSON RPC or from inside, contract to contract call, that you can specify, hey, I want to guarantee it's exactly this version, and if it isn't, I don't want to do the operation. We can make that easier. Easier is better than difficult. Difficult is better than impossible. So we've gotten out of impossible to difficult. We can take the next step to easier. And thanks for that feedback.
Okay. I think that's all of today's workshop. Yep. Yeah. Thanks, Harry, and thanks everyone for joining us. Have a good day.
Thanks. And Sam, thanks for hosting.
Thanks. You are welcome. Bye-bye, everyone.
Bye-bye.